All right, we're on page 183, and the title is Logarithmic Functions as Inverses. Logarithmic functions as inverses. Logarithms are very useful when you have a variable in the exponent that you have to solve for. A logarithmic function is the inverse of an exponential function. So remember we learned about inverses the other day. When you're talking about ordered pairs, it just flip-flops the x and y. That's what inverse is, right? When you're talking about equations and you want to find the inverse, you just flip-flop the x and the y. So if you have an exponential function, an exponential function would be y equals b raised to the x. So you're going to have a base. Your base will have an exponent. When you simplify that, you'll solve the y. Okay? We were graphing exponential functions the first part of section 9. So we had bases, it had an exponent, and remember we had this would be the parent form of an exponential function, and then we had the general form where it was y equals a times b raised to the x, bless you. Or you could have a minus h or a plus h with the exponent, or a minus k or a plus k that shifted your graph up or down. But all of those are exponential functions, okay? When you have that variable in the exponent, exponential function. So a logarithmic function is the inverse of this. So inverse is when we flip-flop the x and the y. Your y would be your exponent, and then your x would come down here. That is a logarithmic function. So we just change the x and the y. Where you see a y, you'll put an x. Where you see an x, you'll put a y. So it's just the inverse of an exponential function. Anybody have questions so far? Okay, so for a logarithm, the way you would write it is log, so logarithm, the word log is just obviously shortened form, abbreviated form of logarithm or logarithmic. You do log base b. Now the base, think about if this is on the line and you know how the G goes below the line, the B is kind of like at the bottom of the G. You got to be careful how you write it. So log base b of x, x is back up on the same line as the word, so b looks like a subscript, and that equals y. The way that is said is log base b of x equals y. Log base b of x equals y. Now, if you watch Algebra Nation, the way they say it is this would be log of x with a base of b equals y. It means the same thing. The way I was always taught, and I've always heard it, is log, you say the base first, base b of x equals y, but it means the same thing, okay? Now, when you have a logarithm, your base must be greater than 0, so you can't have a negative base. Your base also cannot equal 1. And your x value has to be greater than 0. So no negative x value. So this is true if and only if log base b of x equals y. If and only if b raised to the y equals x. Bless you. So I know that looks kind of crazy right now, like what in the world are we getting into? But really, I like logarithms. They're not that difficult, and they're pretty helpful. So what I mean by this is, if 100 equals 10 squared, is that true? Yeah, 10 squared is 100, right? So that would be like an exponential function. If we wrote that in logarithmic form, so we would say then log base 10. 10 is my base in exponential form. It's also the base when you write as a logarithm, okay? So log base 10, the base goes down by the bottom of the G, of 100 equals 2. So to convert exponential form to logarithmic form, I like to label stuff, okay? So this is 10 is my base, or my b. So the base in a logarithm goes down by the bottom of the G. The base in exponential form is the number that has the exponent. Your x in exponential form would be the 100, and in logarithmic form was also the 100, just in a different spot. And then y is the exponent. And in logarithmic form, it's what your, when you simplify log base 10 of 100, it's what you simplify it to equal. All right, so you have to remember what goes where, okay? So this is how I remember it. Some people call it like the snail form or snail method or something like that. I just remember it with a little swirl. So if you start at your base and you swirl around, 10 squared equals 100, okay? So your base raised up to your exponent equals whatever this number is. See, I'm making a little snail there. I mean, you got to use your imagination. Got a little snail going on. So your base squared equals 100. That's how I think of it. And when we get into solving them, if I just said, what is log base 10 of 100? All right, right now you have the whole picture, but if you're missing a number, and usually you're missing this y value, you would say 10 raised to what power would give me 100? So 10 raised to the second power is 100, okay? And also what we'll get into, if you have a base of 10, that's called a common logarithm. And when your base is 10, they won't write the 10 there, okay? It'll be implied. So if you have a logarithm and no base is shown, that's automatically a base of 10. That's a common logarithm. But for now, we don't know that yet, so we're just writing a base of 10. All right, any other base, they're going to write the actual, what the base is. So let's just do another one real quick. If 25 equals 5 squared, so that would be exponential form, then log base what? What would our base be? Log base 5 of 25 equals 2. Very good. Because 5 squared equals 25. Your base raised to your exponent equals 25. So log base 5 of 25 equals 2, or you could say log 25 base 5 equals 2. That's a logarithm. And you're going to see how this is going to help us down the road. Logarithms are going to help us when we're trying to solve for a variable, and that variable is in the exponent. Yes, ma'am?
How do you put that in the calculator?
You don't yet. And the only way you can put it in the calculator is if you have a base of 10. Your calculator won't do anything with a different base. However, we will learn something called a change of base formula, and you'll learn how you can just change everything to a base of 10 and put it in your calculator, but not yet. So I want you to know how to do it by hand, okay? Because a lot of times on these tests that y'all have to take, you don't always get to use a scientific calculator, and so you need to know how to work these kinds of problems without a calculator. All right, but I will show you eventually, just not yet. Anybody have a question? All right, page 184. What is the logarithmic form of each exponential equation? What is the logarithmic form of each exponential equation? Example 1. 81 equals 3 raised to the 4th power. Now, if you saw 3 raised to the 4th power equals 81, same thing. Your b, or your base, is still the number that has the exponent with it. So that's exponential form. Logarithmic form would be log base 3 of 81 equals 4. Just double check, do your little Snell method. Does 3 to the 4th equal 81? Yes, Miss Rayleigh, it does. All right. What if you had 36 equals 6 squared? That would be log base 6 of 36 equals 2. 6 squared equals 36? Yes, it does. Pretty difficult, right? This is not all that logarithms entail. There's a lot more than this. Just this is the base. Example 3. 8/27. Now that's a fraction, but there's no exponent there. I mean, obviously there's a 1, but that's it. Equals 2/3 raised, quantity raised to the 3rd power. So it can be a fraction. So that would be log base 2/3 of 8/27 equals 3. 2/3 raised to the 3rd power equals 8/27. So 2/3 raised to the 3rd power, that means 2/3 times 2/3 times 2/3, right? When you multiply fractions, numerator times numerator times numerator, denominator times denominator times denominator. So that is true. 2/3 raised to the 3rd power is, oh, you can't see that, sorry, is 8/27. Just in case you weren't sure. And example 4. 1 equals 3 to the 0 power. Is that true? Is 3 raised to the 0 power equal to 1? Yeah, anything raised to the 0 power is 1, except for 0 raised to the 0 power is what? Undefined. Nice. So this one would be log base 3 of 1 equals 0. 3 to the 0 power equals 1. Okay, so now we know how to write them, take them from exponential form to logarithmic form, and then you'll need to go how to go back in the opposite way too, logarithmic form to exponential form, if you're asked to do that. But now I'm going to show you how to evaluate a logarithm. How do you evaluate a logarithm? First example, find the value of log base 2 of 8. So this one doesn't tell us what it's equal to, right? And it's equal to y, whatever y is. So this question is asking you to find the y value. That's what we're missing. So what I would do, I would take my problem, log base 2 of 8, and I would write it as a logarithmic equation. Now, when you get used to this, you won't even have to go through all this. Write as a logarithmic equation. Does anybody already know what y is going to be?
Yeah.
What?
3.
Nice. It will be 3. So if you're not sure, go through the process. So to write it as equation, you're just going, right now it doesn't have an equal sign, right? It's just an expression. So put equals, and then y is what it equals to. Not x, not b, but y. And then you're going to rewrite that in exponential form. So now rewrite in exponential form. All right, so in exponential form, you know, think about your little two raised to the y equals 8. 2 raised to the y equals 8. But in exponential form, the y would be over here, right? So really, this is still a logarithm. It's just we're writing it as an exponent. Okay, we really don't care. We're just trying to figure out what that variable is. All right, we already know it's going to be 3. But in case that was something we didn't know, the numbers were larger. Okay, what you want to try to do is you want to say, okay, can I write both of these sides with the same base? Like 2 can't be written with any other base except for 2. 2 to the first power is 2. So you think, can you write 8 with a base of 2? Like, can you write it with an exponent with a base of 2? What's 2 to the first power? 2. What's 2 to the second power? 4. What's 2 to the third power? 8. So we can write 8 with a base of 2, right? So if 8, we wrote it as an exponent, it would be 2 cubed. You're not always going to be able to write everything with the same base. And I'll show you down the road what you do when that happens. But for now, we can write both sides with the same base. So if our bases are equal, then our exponents must be equal. Okay? So if your bases are the same, then take your exponents, set them equal to each other, and now you have found what that exponent is equal to. So I'm going to say if the bases are equal, then the exponents must be equal. Set the exponents equal to each other and solve for the variable. So y must be 3. Is that true? Is 2 raised to the third power 8? Yeah, is log base 2 of 8 equal to 3? Yeah, because if we did 2 cubed, that would be 8, right? So again, on easy ones like this, you're not going to have to go through all this. But sometimes you're going to have problems that are a lot more complicated, and you're going to want to know how to follow these steps in order to find your answer. Know what I'm saying? Do we have a question on that before I turn the page? Okay, page 185. Let's evaluate several logarithms. Number 1, we have log base 2 of 16. So we want to know what that's equal to. So I'm just going to write it as an equation. Log base 2 of 16 equals y. And then I'm going to rewrite it as an exponential equation. So that would be 2 raised to the y equals 16. Can I write 16 with a base of 2? It would be 2 raised to the what? 4. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 16 can be rewritten with a base of 4. And then 2 already has a base of 2. So what is y equal to? Y equals 4. Example 2, log base 8 of 8. What's that going to be? It's going to be 1, right? But let's go through the process. So I would have, just write it as an equation, log base 8 of 8 equals y. And then write it as an exponential equation. So 8 raised to the y equals 8. So if they already have the same base, there's no need to change it, although I could give them both a base of 2 cubed and 2 cubed, but they're the same, so I don't need to. So what is this 8's exponent? 1. So if my bases are equal, then my exponents must be equal. So that means 8 raised to the first power equals 8, and that's true. Anytime you're taking the log of a number that has the same base, it's always going to be 1. Example 3, log base 5 of 125. Y'all want to do this one on your own? Okay. Oh, Travis isn't here. I didn't mark him absent. Anybody know the answer? 3. Awesome. It's going to be log base 5 of 125 equals y. I'm going to write it as an exponential equation. I'm not flip-flopping the x's and the y's. I just need an exponent up there, right? So that's 5 raised to the y equals 125. Are we going to be able to write these with a base of 2? 5, right? And so 5, it already has a base of 5, so that will stay 5 raised to the y. How can you write 125 with a base of 5? 5 cubed. Because we know 5 to the first power is 5. 5 squared is 25. 5 cubed is 125. If you're not sure what base to use, look at your smaller of the two numbers. And if that number can't be written with any other base except for itself, then that's the base you're going to try to see if you can write the other number with the same base. Okay? Because like we won't use 2. 5 can't be written with a base of 2. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. The only base you can write 5 with is 5. So we know y equals 3. 5 cubed equals 125. Questions on that one? Example 4. Log base 5 of, in parentheses, negative 25. Anybody think they know the answer? 5i? I think you can do 5 raised to the I. You want to do 5 raised to the 1/2? Okay, let's see. If I did 5 raised to the 1/2, that's the same thing as the square root of 5, right? and the square root of 5 is approximately 2.2. Is that going to work? No, we need it to be negative 25. Can we rewrite it as 5 raised to the negative 2? A lot of kids think it's 5 raised to the negative 2. What is 5 raised to the negative 2? Is it 25? What is it? What's 5 squared? 25. What's 5 raised to the negative 2? 1 over 25. Is that going to work? No. Let's go back and look over here. The number that's in X's spot, this is page 183, is a negative number. Aren't the rules for exponents X must be greater than 0? Okay. Our X is not greater than 0. It's less than 0. So the reason X has to be greater than 0, you can see that I can't change this to anything with the same base as 5 and get a negative 25. This is undefined. It's not possible. You can't take the log of a negative number. It won't work. So that's why that's one of the rules. X has got to be greater than 0. Coolio? Example 5. Log base 49 of 7. Log base 49 of 7. This is another trickery. I'm not saying it's undefined. It's not undefined. I'm just saying. Do you think the answer is 2? We'll see. Does it work out? You tell me. It's not 2 because 49 squared does not give you 7. I hear a 1/2.
Yeah.
I heard a yeah. All right, so if I wrote this as an exponential equation, how can we write 49 and 7 with the same base? What base would we use? What base would we use? 7. So 7 already has a base of 7, so I'll just say 7 to the first. 49 has a base, if you use a base of 7, it would be 7 raised to the second power, and you already have a y in the exponent. Okay? Remember, when you have a power to a power, that means your exponent has the exponent. The rule says you keep the base, whoops, I didn't mean to put that there, and multiply your exponent. So 2 times y would be 2y equals 7 to the first. Right? So 7 raised to the second power is 49. But you had the y up there, so 7 raised to the 2y equals 7 to the first. So if our bases are equal, then our exponents must be equal. So we'll set them equal to each other, solve for y equals 1/2. Which we know that's true. 49 raised to the 1/2. Doesn't that mean the same thing as the square root of 49? Which we learned back when we learned how to do radical equations, right? Is everybody cool with that? Our exciting bunch today. Alright, let's try this one. I should give y'all a little quiz at the end so all of my sleepers can see what they missed out on. Now, this looks crazy. So my base is 2. Log base 2 of 2 raised to the 5th power. Anybody got the answer?
Is it 5?
It's 5, right? Yeah, because if you put this, write it as an exponent, 2 raised to the y equals 2 to the 5th, well, they both already have the same base. So if their bases are equal, we don't even have to change the bases, right? If your bases are equal, your exponents are equal. So set your exponents equal to each other, solve for the variable. There you go. So that one looks weird, but it's actually the easiest one probably. Anybody have a question? All right, page 186. Now let's talk about common logarithms, which you already heard me say that if you see a logarithm and there's no base written, that's referred to as a common logarithm, and that means that your base is 10, okay? It's implied that there's a 10 there. That is called a common logarithm. Common logarithm. And we're just going to write that down. Any logarithm that has a base of 10 is called a common logarithm. Period. Generally, comma, a common logarithm won't have the base of 10 written. It will be implied. So if you see log of 10,000 equals 4, comma, you will know it is a common logarithm. Meaning its base is 10. I know that's kind of redundant, but hopefully you get the point. So the number 10,000, how many zeros does it have? 4. And isn't 10 to the 4th 10,000? How many zeros does 100,000 have? 5. And what's 10 raised to the 5th power? 100,000, right? So it's kind of easy that way. If you notice the pattern, the number of zeros and the exponent are the same. So just as a quick review, and so you have this for quick review in your notes, what's 10 raised to the 1st power? 10. What's 10 squared? 100. Notice 2 zeros. What's 10 cubed? 1,000. 3 zeros. 10 to the 4th power? 10,000. 4 zeros. 10 to the 5th power? 100,000. 5 zeros. 10 to the 6th power? 1,000,000. What is 10 to the negative 1 power? 1/10. 10 to the negative 2 power? 1/100th. 10 to the negative 3rd power? 1 1,000ths. 10 to the negative 4th power. 1 10,000ths. 10 to the negative 5th power. 1 100,000ths. And 10 to the negative 6th power. 1 1,000,000th is a very small number. It's like 1 out of a million. Very small. So real quick, we're just going to evaluate 2 little common logs. And then I'm going to show you the change of base formula. Actually, let me think. I may save the change of base formula because as soon as I show you that, you are going, because it's how you use the calculator to solve logarithms, you are going to want to use that every time and not show me work. So I think what I'll do is I'll just do 2 examples of logarithms, then I'll give you an assignment so that you have to solve them by hand before I show you how to use the calculator. Okay? And then we'll call it a day. So if I ask you to evaluate log of 100,000. If I made that into an equation, it would be log of, we still don't write the base. That's implied. Now you can if you want to, if that helps keep it straight in your head. Like I probably, because that's just how I roll, I would write the base down to help me remember that when I set it up as an exponential equation, just what I would write. So how would I write that as an exponential equation? Did you say 10 to the y power equals 100,000? Now how can we write those both with the same base? Use a base of 10. So we have 10 raised to the y equals, what is 100,000 with a base of 10? 10 to the 5th power. So we know that y equals 5. 10 to the 5th power gives me 100,000. Easy. Example 2, log of 1/100th. What's the answer going to be? -2, but I'm going to show my steps. So I'm going to write it as an equation. So I know it's a common logarithm because no base is written. So it's log base 10 of 1/100th equals y. Write it as an exponential equation. 10 raised to the y equals 1/100th. I can write both of those as a base of 10. 10 to the y already has a base of 10. 1/100th would be 10 raised to the -2. See how convenient it is we have that little reminder up there in the pink? And so if my bases are equal, then my exponents must be equal. So that lets us know that y equals -2. Anybody have a question? Okay, I'm going to pause this and give you your assignment, and we should hopefully have time to finish in class and be homework free. Hopefully, that's the plan. No questions? Okay.